So I'll tell you the actual what polynomial is. So in multilinear, we have different variables. Yes or no? Like we have x1, x2, x3, x4, like that. But in polynomial, we will have the powers of the independent variable. In terms of the independent variable, for suppose you have experience as the column. For suppose you have experience, now 1.1, 1.2, 1.3 experience in a column. Then the other columns will be squares, cubes of the experience. So in polynomial regression, the independent variable is showcased in the form of powers of n. All right. Did you understand, guys? So if you see the equation of a polynomial regression, let's see. Let's suppose before going to an equation, let's see what is this graph telling about. So if suppose the points are in this way, then you can directly plot a best fit line like this. Yes or no? That's fine. So you can use a linear regression and you can plot a normal straight line in it. But what if your input is in this way? Can you plot a linear line here like this? You cannot say this is a best fit line because there will be so much of difference between the initial value and the final value. I mean the predicted value and the actual value, predicted value and the actual value, predicted value and the actual value. So this is not fine. Then you should need something like this, which is considered as a best fit curve. Yes or no? So in order to find this, first of all, your inputs should be in the terms of powers of n. So this curve will be created whenever you apply the powers of input variables. So here I have only one input variable, which is x1. Then in the second one, I am squaring it. And in the degree 3, I'll cube it. In degree 4, I'll power 4 it. So did you understand the polynomial now? If you see the multilinear regression equation. So here we have a different variable x1, x2, x3. So in multilinear regression, we have x1 as R&D spend. X2 we have as marketing spend. X3 we have as R&D spend, marketing spend, administrative spend, and X4 we have as state. We have different variables, right? But in polynomial, if you see, for suppose you have only experience and salary. If the experience is in a form of linear way, then that's fine. But if suppose the relation between our salary and experience is in a polynomial way, then you cannot directly draw a linear line. We have to draw a polynomial curve. So this polynomial curve will be only possible whenever you showcase the independent variables in the terms of x. So here x1 is experience only, x1 square. That means square of experience, cube of experience, 4 to the power of 4 of experience. So this is how a polynomial regression equation will be formed. So in order to make the machine understand that this is a polynomial features, you have to incorporate polynomiality in the algorithm. So how can you apply the polynomiality in the algorithm? You have to give the powers of the independent variable. So have you seen the difference between the multilinear regression and the polynomial regression, guys? And this equation will be based on powers, the degree of powers. For suppose if you give 3 degree, then it'll go up to cube. If it is 4 degree, then it will go up to 4 degrees. Did you understand, guys? Did you understand now? Srividya, did you understand now? Yes. So now let's see how can we solve the equation. How can you give the equation? I mean, how can you get the value of x1, x2, x3 and x on and so on? Okay. First, suppose I'll just explain in a Word document. Okay. First, suppose I have experience in this way. 1 year, 2 year, 3 year, 4 years, 5 years, 6 years, 7 years. Okay. Now I have output as 10,000, 10,000, 1 lakh, 10 lakh, 1 crore, 10 crore, 100 crore. Now, can you say that this is a polynomial kind of thing? It is not a linear one. It is increasing exponentially. Can you consider this output as a polynomial? Yes, this is increasing exponentially. If suppose you put a linear kind of thing, then that y is equal to mx plus c will not give the accurate output. So that's the reason what you have to do. First of all, you have to give the powers of your inputs. So here what I am doing, I'm just giving the degree as 4. Degree as 4 in the sense 4 powers. So that means now after polynomial, now it will become this becomes x bar 0, this becomes x bar 1, this becomes x bar 2, this becomes x bar 3, this becomes x bar 4, and this becomes the output. Now here x bar 0. 1 bar 0 is what? 1 bar 0 is what, guys? 1 bar 0 is what? So 1. 2 bar 0 is 1. 3 bar 0 is 1. 4 bar 0 is 1. 5 bar 0 is 1. 6 bar 0 is 1. 7 bar 0 is 1. Now x bar 1 is 1. 1 bar 1 is 1. 2 bar 1 is 2. 3, 4, 5, 6, 7. Now x bar 2 is 1, 4, 9, 16, 25, 36, 40. Right. X bar 3 is 1, 8, 7. Seven power 4 is 241, right? 7 power 3 is 241, right? Guys, 1 minute. My system got stuck. Okay, fine. Thanks. Yeah. Now x power 4 is 1. अरे यार. So this is how it becomes. So now the equation will become, our equation will become y is equal to a naught plus a1. That is, here anyhow we have 1, right? Plus 1 plus 1 plus a1 into x1 will a1 into x1 plus a2 into x1 square plus a3 into x2 square x1 cube plus a3 into x1 to the power of 4. So this is our equation now. Now how do we calculate a1, a2, a3 and a4? Can someone tell me? Oh, sorry. How do we calculate a1, a2, a3, a4? Can you please tell me, someone? Can someone tell me? Any guesses? Any guesses, guys? How do you find A1, A2, A3 and A4? Oh, really? Is that a formula, Prasanna? What is that formula? If you have completely understood the multilinear regression and linear regression, you would have told this in a very span of seconds. So that means you didn't even understand linear and multilinear regression. That's what, right? Which is nothing but slope between x1 and y, which is equal to sigma of x minus x mean into y minus y mean divided by x minus x mean. Then A1, A2 is nothing but slope of x1 square and y, slope of x1 cube and y. Next, slope of x2 cube, x1 power 4 and y, right? So these are all the slopes. Once you get the slope, then you have to calculate A naught. How do you calculate A naught then after you find the slopes? After you find the slopes, how do you calculate A naught? Guys, how do you calculate? How do you calculate A naught after we got A1, A2, A3 and A4? You said, everyone said you understood multilinear and linear regression, guys. What are the values, Shivakumar? Only Shivakumar is the one who's in the class, right? This is very ridiculous, guys. Can you please tell me what are you learning in all these classes? None? Is it zero? Very good. So even I'll tell in my version. Fine. If no one is responding to me, I'll go in my own way. So now after you have to substitute all the means and you get an equation. All the means you get A naught. After you get the A naught, you will form a perfect curve equation. Perfect curve equation. After you form a perfect curve equation, then apply the actual values. Apply the actual values. See the predicted value. Again, check predicted output and actual output. Check predicted output and actual output. Do the calculation of error. Change the slopes. Find the equation. Again, apply the values. Check the prediction value and check the predicted value and the actual output value. Again, calculate the error. So check where is the minimum error. Wherever you get the minimum error, that is considered as the perfect curve. So this is what polynomial regression is. So let's get into the practical assumption, practical part, guys. See, guys, if you don't respond to my questions or anything, I'll go in the same way. I don't know. I don't want to wait for anyone. I'll just say whatever I want. Now let's go to the practical implementation, guys. So before going into the practical implementation, I would like to send the document in the Slack. Document in the sense the data set in the Slack. So please do download the data set. Please download that. We'll go on to the practical implementation. On that day, I again took an example and again said you the whole linear regression. Same phenomena you find everywhere. That means 4 times I have discussed the same thing. When I ask you, none will answer. So from today, guys, I have decided not to ask whether you have understood or not. I'll just keep on going in my flow. If you understand, that's fine. If not, I am not responsible. So please, guys, download the data set. Once you download the data set, let me know. We'll start the practical implementation. So guys, done? Thank you so much, guys. Yes. So likewise, we did for linear regression and multilinear regression. I will be first importing the libraries. Import numpy as np, pandas as pd. So after loading the data set, we will discuss what data set we are working on. All right. So now the next one is to read the data set. So I'm just giving a variable name called data set is equal to So I've just now read the data set, and let's look into the data set. If you just open the data set, here I have position. The position is business analyst, junior consultant, senior consultant, manager, country manager, region, and I have some sort of 9 positions. So each position is given a level. So business analyst is given as a level 1 and CEO is given as the level 10. So those salaries are being showcased here. So here, if suppose he is level 1, then he'll have 45,000 as a salary. If he has 2, he'll have 50,000 as a salary. If his level is 3, he will have 60,000 of a salary. So if you see this, there is some sort of exponential increase of salary. So the difference between salaries of one level and the second level is just 5,000. But the difference between 5,000 and 50,000 and 60,000 is 10,000. So if you see, this is exponentially increasing but not linearly increasing. Exponentially increasing but not linearly increasing. So let's see whether this is exponentially increased or linearly increased. So for that, what I'm doing is I'm just importing my matplot library. Now I would like to plot the graph between level and the salary. Just execute. So can you see how our data set, can you see how our values are? So now can you tell these are exponentially increasing or linearly increasing? These are exponentially increasing. So whenever the data is in the form of exponential form, the relation between x and y, you cannot draw a linear line. Even though if you draw a linear line, that is not considered as a best fit line. So for this, something like a curve, something which is, so if I just show that in the paint. For suppose your points are like this. This is not considered as a best fit line because the value between the predicted value and the actual value will be very different. So there should be something a curve like thing which looks like this. So then you can consider this line as the perfect curve. So in order to find this perfect curve, first of all, you have to apply some sort of polynomial features to the input. So I've already told you in the Word document, right? So here what I said, what I showed first, I have only one value. Then I am converting that into polynomial features. So polynomial features is nothing but I am giving a degree power to that. So whenever I'm giving a degree power to that, for suppose if I give 4 degrees, then 4 powers will be given. If I give 5 degrees, then 5 powers will be shown. After that, I am just forming a polynomial equation. Once the polynomial equation is formed, then everything that we have applied for multilinear, linear will be same. So first, your slopes will be calculated, your constant will be calculated, then a equation will be formed. To that equation, you will be applying the x1, x2, x3, x4 values. You will be comparing or checking the actual value and the predicted value, and will be calculating the error. So like that, you will continue till you get the minimum error. So wherever you get the minimum error, that is called as the perfect curve in the polynomial regression. So here in this example, I would like to show you the linear regression program as well as polynomial regression program, so that you can understand the difference between the linear line and the polynomial line. All right, guys. So done till here? If so, I'll move forward. Yes. So let's see whether we have any null values or not. So I don't have any null values now. So is this the necessary to convert anything into the label encoding and one hot encoding? So here, anyhow, a numeric value is directly associated to position. So here, if you give 1 or as business analyst, that is same, right? So as you have this, as you already have this, what I am doing is, I am not considering the position because we already have level, right? Right? So I'll be only considering level. So no need of label encoding and one hot encoding as well. All right. So for that, what I would like, after that, what I would like to do is, I would directly like to convert this into X and Y, that is split into X and Y. Anyhow, I am representing a numerical value to business position, right, sir? It's fine. You can just take level. Anyhow, level is representing the position itself. So why again considering the position? So as I'm not considering the position, label encoding and one hot encoding is not at all necessary. So for that, what I am doing is, X is equal to dataset of dataset dot ilog of all rows comma 1:2 dot values. Y is equal to dataset dot ilog of all rows comma 2:3 dot values. So my X and Y are created. So in X I have level, in Y I have salaries. All right. So here, as I have only 10 rows, I'm not splitting the data into train and test. Directly I will train the algorithm on X and Y only. So before, what I would like to do is, I would like to apply linear regression. I would like to apply linear regression. After that, we will apply the polynomial regression. So what is the library that is used for linear regression? Did you remember? So I'm directly using X and Y, guys, because even though I split the data into train and test, 2 rows will be test, 8 rows will be train. So 2 rows testing is not at all a feasible one, right? So I'm directly using X and Y. Now tell me the library for linear regression. Model underscore selection is for test and train and split. Roshni. So from sklearn dot linear underscore model import linear regression. Now what I'm doing, I'm just giving a name as LR. The linear regression linear regression name is LR. LR is equal to, I'm calling the instance of the linear regression, and I'm creating an instance of the linear regression. Yes, I have created it. Now what I want to do, LR dot fit of X comma Y. So my linear regression is trained. Now what I want to do, I would like to just predict the linear regression value. So for that, predict the linear regression value. So for that, what I'm doing, LR dot predict of X. Execute this X. Now see Y. So year is 1. For 1 year, the output is 45,000. But our model predicted as minus 11454. Is this correct? Is this correct, sir? Correct, guys? So I have 1 year. For 1 year, the answer is 45,000. But my linear regression gave as minus 114454. There is a lot of difference between the predicted value and the actual value, right? The reason is the output is in exponential format. For that exponential format, a linear line is not suited. So I would like to draw a graph between so here LR predict, I am giving it as P pred, LR pred. LR pred is equal to predict of Y. Now X comma LR pred. Just execute this. Now, can you consider this as a perfect line? So here, this is the last value, but the difference between first and last value is so much. The difference between this and this value is so much. So you cannot consider this as the proper best fit line. So for that, you have to first apply polynomial features to the X. So done till here, guys? Done till here, everyone? Yes. Now let's apply polynomial regression. So what first step is to call the polynomial feature creation function. Second step is to apply the polynomial features to X. Create the equation of polynomial data. Next one, call the algorithm. Fifth one, train the algorithm. So these are the 5 steps that will be there. Guys, can you please turn your cameras off? So first one is applying the polynomial, call the polynomial feature function. So this polynomial feature function will be called with the help of a library. So I am importing the library. So what is that library? From sklearn dot preprocessing import polynomial features. So next one is call the polynomial creator function. That means you can also call it as creating a instance for that. So what I'm doing, I'm just giving a variable called poly_reg. Poly_reg to the function that I would like to call. Polynomial features of degree is equal to 4. So before running this code, what I would like to do is I would like to see what is the X. So X has only one column which has levels as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see the X of shape, X dot of shape. So what is the X dot of shape? It is 10 rows and 1 column. So after applying this polynomial features, let's see how our X gets transformed. All right. So now the second step is to call the function of the polynomial features. Then it is apply the polynomial features to X. Apply the polynomial features to X. So here what I'm doing, I'm creating another variable called xpoly. X_poly is equal to, I've created a variable called polyreg with degree 4, right? So with the function, I'm passing the argument dot fit of transform of X. So here also what I did, first I have only this one, then I am fitting my X values to the degree, powers of the given degree. So here also what I am doing, I am making my X as degree as 4 and I'm storing these values in xpoly. So my X will have 1, 2, 3, 4, 5, 6, 7, 8 and my xpoly will have all these values. So let's see whether that is happening or not. Just execute this. Now x underscore poly. So 1. All these are ones. Yes. Here also all these are ones. Now I have 1, 2, 3, 4, 5, 6, 7. Do you have that? 1, 2, 3, 4, 5, 6, 7. And here also I have 1, 4, 9, 1, 2, 3, 4, 6, 8. Yes. So 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square. This is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cube, 7 cube, 8 cube, 9 cube, 10 cube. 1 power 4, 2 power 4, 3 power 4, 5 power 4, 6 power 4, 7 power 4, 8 power 4, something like that. So now all these polynomial features have created or not? Like the same thing? Yes. Now what I am doing? I am creating the equation of my polynomial curve. So for that what I do? Poly underscore reg dot fit of x underscore poly comma y. So here what I am telling is x poly comma y, right? So that means for the first row, the answer is 45,000. For the second row, answer in the sense the output is, the second row, the output is 50,000. For the third row, the output is 60,000. So I am just making my x poly as inputs and the y values are respected outputs to the x poly. Now once that is done, then I will be fitting the algorithm. Fitting the algorithm is nothing but the training the algorithm. So now the equation looks similar to multilinear regression, but the powers of x. So for multilinear also we have used the linear regression function only, right? Because the back-end functionality is same. So for polynomial regression also, I'll be using the same linear regression function, but the variables as x poly comma y instead of x and y. So for that what I am doing, polyreg is equal to, polyreg is equal to linear regression. Polyreg is equal to linear regression. Now I am fitting the values to polyreg. Polyreg dot fit of x underscore poly comma y. Because I have to train the algorithm between x poly and y. Okay, it's not x poly, it's x underscore poly only, right? Yeah. So now my polynomial regression is created. Poly underscore reg is for degree, for maintaining, for creating the equation. This is my algorithm. So now my polynomial regression is trained. Now let's predict them. Poly reg dot predict of x underscore poly. Now if you see 5356, now let's see y. Now if you see, it is somewhat fine. 5356, 45,000, 50,000, somewhat fine when compared to linear regression. Now I would like to draw the graph between these two. So here I would like to put it as P pred. Now, can you consider this as a best fit curve? So instead of a linear regression, I would apply a polynomial regression by making my independent variables as powers of the input variable. All right, guys. Now let's see the accuracy. From sklearn dot metrics import r2 underscore score. Import r2 underscore score. Lean LR accuracy is equal to LR R2 underscore score of y comma LR pred. Poly accuracy is equal to R2 underscore score of y comma P pred. Now LR accuracy, linear regression accuracy is 66. Polynomial accuracy is 99%. So now did you understand the difference between this polynomial features and the linear regression and all? Yes? So this is what all about polynomial, linear and multilinear. I'm just putting this program in the Slack. You can directly use it. Any doubts? Any doubts? So again, I'm telling from the features. Sangeeta, did you understand this? Shivakumar, I'll tell you once. Sangeeta, did you understand this concept? What we did? We have converted the single feature into powers of the degree that we have given. Yes, that's what I have given here as well. So first my x has 1, 2, 3, 4, 5, 6, 7, 8, 10 in one column. After that, I am calling a function. So in the first step, call the polynomial feature creation function. So I'm calling a function which is used to create the degree of an equation. Yes. After that, here what I've mentioned, I'm given degree as 4. All right. So after I give degree as 4, what I want is I want to apply this degree to my x. And I have put that in another variable called x poly. So now my x poly has polynomial features. If you see here, right? After that, I am applying linear regression. After that, I am applying, creating a feature, creating a equation for my polynomial regression. So here I have created a equation, right? A1 plus A0 plus 1 plus A1 x1 plus A2 into x1 square plus A3 into x1 cube plus A4 into x1 4, something like that. So here also I am creating my polynomial equation with degree 4. That means what I am telling is here, this also means that you are giving the same outputs as y to x poly also. So here the outputs are 1,000, 10,000, 1 lakh, 10 crores, right? So here also you have output as 1,000, 10,000, 1 lakh, 10 lakh, crore, 10 crore, 100 crore, right? Yes. So the first row is having the same output of this one and this one. The second row is having the same output of this as well as this. So here also I am fitting my x poly and y together. Once that is done, I am applying my algorithm. After applying algorithm, I am just predicting my values. Now I got my y. So if you just plot the graph between polynomial and all, you can see a graph like this. And Shivakumar, if suppose your accuracy is less, then you can increase the degree. So the ideal degree I gave is 4. You can also give 5, you can also give 6, you can also give 7. Did you understand, Sangeeta? Hope your question is also answered, Rakesh sir. As the degree increases, there will be change in accuracy. Now, let's predict the random values. Okay. So, here my polynomial regression is polyreg, right? Control C. Polyreg dot predict of double array. So how many values I have to give here? Can someone tell me? If you tell this, guys, that means you have understood the concept very properly. Not polynomial concept, the algorithm building concept. If none says, then that means none of you understood anything from the past classes. Let's see who will give the right answer. Srijna said it's 1. So can you please tell me what are 2? Haripriya said 2. Pramod said 1. Okay. So can you please tell me why 1, why 2? Blindly are you giving the answers? Or are you thinking of something? Srividya 1. Bhavani 2. Guys, are you thinking and giving me the answers or blindly giving, just blinking the, just giving the... Okay, fine, Srijana. Why 1? Can you please tell me? Can you please tell me why 1? Okay. Have you not created into a polynomial features? How many values do you have after creating the polynomial features? So whoever said 5, that's really correct. Correct, guys. Good. So out of 145 people, I find only 6 to 7% who understood the things properly. Very good. So yeah, so whoever said the right answer, can you please tell me what are all the values that I have to give here? Asma, you tell me. You gave the right answer. You tell me what are all the values that I have to give here. Asma, are you there? Yeah, tell me. What are all the values that I have to give here? Tell me what are all the values, guys. Asma, tell me. Your answer is right. So should I give like this? Is this right format, Asma? That's really good. The first one will be 1. That means 1 power 0 is 1. For suppose if you want to give 12, okay? 12 as the years. All right? For suppose you want to predict 12 as the years. So first one, 12 power 0 is 1, comma, 12 power 1 is 12, comma, 12 into 12 is 144, comma, 12 into 12 into 12 is 1728 into 12 20736. Yes, so this is how you have to give. But if you want to give higher values, this is not the right way. You have to again calculate it and again you have to give it. Instead of that, you've already created a function which is giving you the degrees. Am I right? You've already created a function which is giving degrees. So here only you have formed that, right? Yes. So instead of you giving all those things, you can directly give in this way. You can directly give in this way. So polyreg dot predict of poly underscore reg dot fit underscore transform of 20 years. So this function will automatically convert 20 into degree of 4. The reason we have already created a function for converting the data into polyreg is not defined. What is the difference between this polyreg and this polyreg? Both are same, right? Yes. Understood, guys, this one? Now here I have given my value as 12, right? So I'll just give it as 12. So can you see that both answers are same? Now here I want to give it as 20. Now if you want to give in this way, 20, 20, 20 square is 400. 20 cube is what, guys? 20 cube. It is 8,000. Next it will be something like 160,000. Right? So if you do it, the same answer you will get it. So this one and this one are similar. So did you understand this, guys? Only for polynomial regression I am telling. Did you understand this now? You cannot take that in linear and multilinear, Shrija. How can you take that in linear and multilinear? In multilinear, you have specified columns for specified inputs, right? So this is what polynomial regression is.